Yesterday we ended up finishing up this problem about the special problem. What I want you to do is we have this one. X, or 2x squared plus x minus 1, all over 9x squared minus 9x plus 5. Which of the two methods that we were taught yesterday would you use? Why would we use the x-intercept method? Because it's equal to 0. Good. So put this in your calculator and see what happens. All right, when we have this problem, a lot of you sat there and looked through, and first thing you graphed, zoom 6. You see, let me wait till it stops, bring it over here, make it bigger so you can see it a little bit better. It goes like this. Then it stops, then it starts up again, right? Something happens in here. What I'm going to do, a lot of you zoomed in, zoomed in, zoomed in. There's a problem if I keep zooming in. If I do zoom in, all right, I see a little bit more. I can work from here and find out what that one is. A lot of you went a little bit further. And you had this one here. There's a slight problem. How many zeros should there be? Two. There's one here and one here. I want to keep them so they're in one window. I want to go back to what I had. Go back to my flat line. What's the only part I really care about? The missing part. Zoom box. Go to the left and a little bit above. So I'm going like right, putting my cursor right here. I press enter. Now I move it to the right. So it's past the opening. Now I go down till it's down below it. You did this in Treg last year. I hit enter. It goes down right here, or it has a zero right here and right here. I have an intercept right here and right here. Those are my zeros. What does this one look about? About 1. How do I find the zeros? Second trace 2. What do you want my left bound to be? -2. What do you want my right bound to be? You want it past the first one. You don't want to go to the 0. My guess, that's good. This matters where you tell my left and right because there's 2. If you go and get them both in one window, it messes up. Press enter. My first 0, x equals -1. Why is it not approximately? It's equals -1. Now the other one, second trace, 0 again. What do you want your left bound to be? 0. What do you want your right bound to be? 1. My guess is 1. That's good enough. My answer is 0.5. Those are my zeros. Those are my solutions. All right, for this problem, this is a new problem. I'm going to type it in. I made sure they're in parentheses. When I do zoom 6, because I got to go back because I was messing with the zoom in the last problem. And then you have this thing that happens. On this one, you notice it starts, it goes down, there's a straight line, then it goes down. The calculator's drawing something different. The calculator's drawing these asymptotes. This line is not there. What happens? The graph goes like this. Let me grab a thicker pen. Fine, I'll use this one. It goes like this. And then all of a sudden, once it hits this point, it does this. And for right there, it does this. Then all of a sudden, it goes like this. It looks very, very bad. When you have a problem that looks like this, we're going to do it a different way. See, this one, we're able to manipulate the screens to be able to find everything, right? What I want you to do, just graph the bottom. All right, the mistake I had, you can't just graph the bottom one. You need to graph the top one. I circled the wrong one. We're going to disregard this bottom piece. We're just going to look at the numerator. So in my calculator, it should be an easy fix. Y equals, I'm going to delete the whole divided by part. When I hit graph, what do you notice? It's normal. I only have 1, 0 right here. If I could take this graph and put it over top, what are you going to notice? It's in the same spot. Just you don't have all of this stuff to worry about on your screen. You can actually sit there and go, that's my only 0.
Oh, that's the part right there at the bottom.
Right. What it's doing is it's combining this one, and then this is changing it to look like this. You're taking out this part that's going to give me the asymptotes. I just need to find the 0 right here. Second trace. Okay, 0. My left bound, I'll use 0. My right bound, 3. My guess, my answer is about, x is about 2.279. Now if I erase this right here, there's 1, there's 2, it's 2 point something, which is the same exact number. What happens if I do that for this problem? Will I still get, let me bring these, if I get rid of the bottom on this problem, if I get rid of the bottom on this one, what happens? Go see if it happens. See what happens. When I take just the top and I hit graph, yes, now it's just a parabola because it was squared. But if I look at these zeros, this one's at 1/2. This one's at -1. So what can you tell me then? What can you tell me if you have a... Right. If you have a problem that had numerator, denominator, the only thing you need to put in your calculator is a numerator. Don't even worry about what's on the bottom. So you just put in the top, get your zeros from there. That dividing function does not change your zeros. That's what I wanted you to find out. Any questions on this? We're good on the intersection method. We're good on the x-intercept method. You understand that if you have a fractional problem, you just need the numerator. And you can use the graph to tell me how many intercepts I have.